Hi and welcome back to another LeetCode video. Today we're looking at LeetCode 3560, find minimum log transportation cost. This is an easy problem. We're going to do our usual thing where we try to solve the problem interview style, focusing on communications, clarity of thought, coming up with a solution before we write any code, and giving runtime and space complexity before writing code as well. So let's see how we do with this one. So we're given an integer, we're given integers n, m, and k, 3 integers. There are 2 logs of length n and m units, which needs to be transported in 3 trucks where each truck can carry 1 log with length at most k units. You may cut the logs into smaller pieces where the cost of cutting a log of length x into logs of length 1 and length 2 is the cost of the length multiplied, such that the sum of the length is x. I see. So we have a log that has a certain length. If we cut that, the cost of cutting that is the resulting length multiplied. And that the total length of the 2 after cutting is the same as the length before cutting, right? And we should return the minimum total cost to distribute the logs onto the trucks. If the logs don't need to be cut, the total cost is 0. Interesting. Oh, okay. So n, m, and k. I kind of want to know what values they can take. Can they be 0 or are they always going to be positive? And LeetCode tells us in the constraint section. So k, what was k again? K is the length of the logs that a truck can carry at most. So that is at least 2. Now the length of the logs is at least 1, and the sum of them, and each of them is at most twice the size of what a truck can carry. Okay, so nice. So that's kind of some variable naming kung fu. Maybe we should rename them just for clarity, you know. So we have truck capacity, that was okay. Right, so that makes it a little bit more clear. What is n? 2 logs. So n is log 1 length. And m is log 2 length. I think that is more descriptive. Log length. Let me just unify how I name the variables here. I'm going to have some camel case. Right, so we have the 2 logs of different length and we have a truck capacity and we know we have 3 trucks. Okay, cool. So now let's look at the example. So here we have 2 logs of length 6 and 5 and our 3 trucks can at most carry logs of size 5. So I suppose we can put the first log into the truck and ship it, but we have to cut the second log into 2 pieces. And okay, so now there are different ways of cutting the log, right? We could cut it into 2 logs with length 3, but the cost would be 3 times 3. That would be 9. However, when we cut that into a log of length 5 and 1, then the cost would be 5. So it's much lower. So I guess, so the first hint here is that when we cut logs, we probably want to cut it just so that it fits exactly the size of our truck capacity, right? That's what we want to do. So we cut it into a piece of 5 and a piece of 1. The total cost would be 5. That's why we output 5. Nice. Yeah, and that's exactly what they describe here. Cool. Second example. So now the truck capacity is 6 and we have 2 logs of size 4. Both fit into the trucks, so we have 0 costs. Nice. Okay, so yeah, I think what we can do, well, since here the length of the logs. Oh, and by the way, there's an important point we just missed. The input is generated such that it is always possible to transport the logs. Okay. So that means that we have to check. What do we have to check? Well, if we have a log that fits into the truck, well, if both logs fit in the truck, we just ship it. We have 0 costs. if we have, so I wonder, since we have 3 tracks, right? So at most we have to perform 2 cuts. That's when we have to cut both logs. That's what we need to do. Now I'm wondering whether it can be that both logs need to be cut, or if it's that we can only have to cut 1 log. Well, let's deal with the case where we cut only 1 log. So the first log to cut, I suppose, would be the one that is longer. So maybe we should sort them first, right? So what we can do is we can just take the minimum and the maximum of the two. The maximum. Right. Now, if the minimum log is smaller or equal than the maximum, we know they both have the same. Wait, if the maximum is smaller than the truck capacity, we have 0 cost, because both logs are going to fit into the truck. So maybe we need to have a cost variable here. Cost equals 0. At the end, we're going to return that. And I'm actually getting ahead of myself with the implementation, which I shouldn't do. But I think we can solve this in O of 1 time and space. Yeah, I should have said that. And then, so what I'm thinking is we just need to perform the checks. Which log do we need to cut? Then we cut it so that the logs fit exactly into the truck, and then we just ship it. Right. So if the smaller log of them is smaller than the capacity, we know we have 0 costs, right? Otherwise, well, we have to perform some cuts. Okay, so if we have to perform cuts, well, what do? We will cut the longer log, right? So that would be the length 1 that we have here in the description. That would be the truck capacity. And the length of the other part of the cut log, that would be, well, it would be log length 2 minus length 1, or minus truck capacity. Right, and so now we have to add to our cost 1 times 2. That's pretty much it. So, and we could also write this maybe a little bit more easier. The one-liner, oops, times that. So that would be the cost that we need to add. And that is splitting the log 2 so that it fits into 2 trucks. Now, in the example, it doesn't say whether we have to actually cut both logs, but it tells us that we have to, that both of them fit into the 3 trucks. So what we can also do here is, well, if log length 2 is larger than the truck capacity, that means we also need to cut that one. And we can perform the same math here. Now, because in the constraints tells that the input is generated such that it's always possible to transport the logs, that means that even if we cut both logs into chunks, all of the parts that we get are going to fit into both of the trucks. And I think that is going to be the whole solution. And if you look at it, minimum and maximum of 2 numbers, that's constant space and time. And everything else is also just constant time and space. So let's just run it through the test cases here. And it passes all of them. Nice. So now we just submit this to see what happens. And we pass all of the test cases. Very nice. And that concludes that problem.